Now, all right, students, I'm going to go ahead and now address lesson 25A, polynomial equations and equations in quadratic form. Okay. So now the essence of quadratic form is, again, this concept of being, and I actually forgot to put it there, but it's in the form of this right here, where we have this quadratic. Now, we want it to be in this kind of form where it's 2, 1, 0, right? Because that's the kind of form we're looking for. Well, sometimes equations aren't set up that way. And they're matter of fact, set up like this, where they look very intimidating, okay? Because now it's talking about multiple accounts of variables that are beyond the 2. But it actually is in the form of a quadratic if we kind of manipulate it to be that. So what I'm going to do with this equation right here is I'm going to factor, okay? So let's go ahead and look at that. Now, if we go ahead and factor, we can see that they both have at least minimum 3 k's, as well as we can factor out also a 4. But because I want my leading coefficient to be positive, I want to go ahead and factor out a negative 4. So what I'm going to do is factor out a negative 4k to the third. And if I do that, then I'm going to go ahead and be left with x to the, or not x, but k to the second. And then I'm going to be left with negative 9 for the value of that, because I factored out a negative 4k to the third. Now, when I look at this, I can see that this is a difference of 2 squares. And when I have the difference of 2 squares, I'm going to go ahead and get this. And then, of course, I still am remaining with this over here. And what I do is I go ahead and factor, or set each factor equal to 0. So I'd have negative 4k to the third set equal to 0, and that means k is equal to 0. And then I have k equals negative 3, as well as I have k equaling positive 3. So there is our values for solving this, and we're kind of done with this problem. And you can see the 0 and then the plus or minus 3. So now this one wasn't really that complicated. However, you did see the fact that it wasn't in the quadratic yet. We had to do some factoring to get it there. Now, when we look at this one right here, okay, let's take a look. We have the strategies for this one. That's a 3. And then look at this. All right, now what we want to do, just like we've done in all the other kinds of problems that we address, is we want to isolate everything to one side of the equation. Now, I like to keep, again, my leading coefficient of the highest degree power positive. So I'm going to bring everything over to the right side. And when I do, I get s to the third, and then plus 3s to the second. And then I'm going to go ahead and get minus s minus 3. Now, I set that equal to 0. Now, the thing that I see here is I have a 4-term polynomial. When I have a 4-term polynomial, something leads me to believe that I'm probably going to have to use factor by grouping. So factor by grouping is where you take and group the very first 2 terms together and group the second 2 terms together. So first 2 terms, second 2 terms. I mean, you know, like it's the way you say it. But anyway, so you have 2 factors. Now, what the thing is, you're going to factor out between this is an s to the second, right? Because there's s to the second in both of them. And we're going to get s plus 3. And then I go ahead and see that I can factor out a negative 1 between these 2. And I'm going to get an s plus 3 as well. If factoring by grouping works effectively and appropriately, these 2 terms should match up together. If they don't, then maybe evaluate what you did. Perhaps you did something wrong. So now what I do, and I tell students, is since you have these 2 terms matching, take the terms that are in front of them and group them together. And then take the second term that is double underlined and write it as 1. All right, that's factor by grouping. Now we go ahead and see that this is factorable because it's the difference of two squares. So it's s plus 1, s minus 1, and then s plus 3. And then, of course, if you set each equal to 0, then you're going to get s is equal to, okay, I'm going to put an arrow here. All right, s equals negative and a positive 1. So I'm going to put plus or minus 1 because I'm being lazy. And then I'm going to put minus 3. So there are our answers for this. So 1, positive 1, negative 1, as well as the negative 3. So that's factor by grouping. So that strategy you would use here as well. This is a 4-term polynomial. I will choose not to do that. I will go ahead and defer you to understanding that it's completing the square on this one as well as this one. They like to use the completing, the factor by grouping method. Whenever it's a 4-term polynomial, especially with x to the third, it's really easy, and you're doing it through that process. Now with this one, okay, this one's not going to be too different. You're going to go ahead and do what we did on this particular one right here. All we have to do is bring the 648. I would actually bring over the c, or 3c to the 7th to the other side, so it's positive, and then you'd factor out 4 c's as well as factor out a 3 to both of them, and then you're doing everything we just did kind of in this process here. All right. So yeah, I don't see any reason to be alarmed on this one. And now I'm doing something a little different on this one. Okay, so number 7 is different. Okay. So number 7, we have p to the 4th minus 29 p to the 2nd plus 100 equals 0. Now, I have to teach you what's called U-Substitution. It's something you're going to have to use in upper level maths if you go that direction. It's going to be a little bit more difficult that level, but it's going to be the same concept. So what we do is we let U represent something. And what we're going to let U represent is whatever is in the middle term here. And watch, there's going to be a reason for it. You're just going to have to trust me. So b squared is what we're going to let U equal. P squared, I meant. All right, so if we let P equal, or excuse me, U equal P squared, then if we think about it, U squared, if we, not that we have to do this, I'm just letting you know. If we say U squared, then if we square both these two terms, what are we going to end up with? Hey, wait a second, we're ending up with P to the 4th, the same thing that's here. So what we do is we say, well, then this P to the 4th is equal to P, or U to the 2nd, and this number, the negative 29, then becomes just negative 29U plus 29, or plus the 100 equals 0. So, and I'm going to do a couple more of these where I'm going to represent the middle term by U, and I'm going to substitute in that U so I can get back to a quadratic. That's why this is called U-Substitution, is because we want to substitute it in to get back to what looks like the form of a quadratic. Now I talk to myself and I say, well, what two numbers multiply together to create 100 to add up to 49? And we're thinking maybe 25 and 4, because 4 quarters equals $1. And so we're looking at U. And by the way, this is positive and this is negative, so these are going to have to be both negative. So then that was interesting. Okay, 25. All right, and then we have U minus 4. All right, and now we're looking at U equals 25, as well as U equals 4. All right, now when we look back, what does U represent? U represents P squared. So what we do is we substitute back in the P squared for that value of U. And then of course it's not, P isn't by itself yet, so we take the square root of each side. That eliminates that, and we get plus or minus sign. So it's going to be P is equal to plus or minus 5, as well as P is equal to plus or minus 2. because the square root of 4 is 2. All right, and there we have our answers for this. Now that was a little different for you. That is definitely something out of your comfort zone because you haven't never done something like that before. So all the rest of the stuff you've done before, perhaps, maybe factoring you've done, not something like that though. So it's called U-Substitution. And we're going to do a couple more of them because I know you're not riding your bike by yourself yet. So let's go ahead and do a couple more of these. All right, well, this is going to be very familiar from the other one because it's not anything different I'm going to approach it. I'm going to go ahead, write the problem down, and you know what I'm going to write next. I'm going to write U because it's called U-Substitution for a reason. So it's the same exact approach. So U is going to represent not P this time, but X squared. And then U squared is obviously then P or X to the 4th power. And that's always going to be represented for what we have here, right? So it should, if it's in the form of a quadratic, it will be that way. So we're going to have U squared, right? And it looks like we're getting back to our quadratic form. Then we have this. And now we're back in our quadratic form, the 2 and the 1 and the 0. That's why I pointed that out to you over here. I was making sure to make reference to that, right? So now we're going to go ahead and factor this like we do normally. So it's what two numbers multiply together to create 35 that add up to negative 12. And then we're thinking about maybe 7 times 5. That sounds like 7 times 5 works because 7 plus 5 is 12. So it's going to be, I loved it when I put accidentally. Gotta love mistakes. Okay, so 7 and 5. All right, and now we're going to say then U equals 7 and U equals 5. Well, now U represents X squared and, X squared. So I'm going to write X squared equals 7 and X squared equals 5. And then square root both sides, and then I'm going to have plus or minus 7 and plus or minus, and I say 7, but I square root of 7 and then plus or minus square root of 5. I can't take and simplify them any further, and there becomes our answer. That's why you have so many of these. Plus or minus, the square root of 5, and then the plus or minus square root of 7. Like the same answers that I have here. All right, so that is the heart of substitution. Now, we got to do some more. I know you're like, oh man, I'm not feeling that comfortable yet. This is a little different. This doesn't look like a quadratic at all. And it's not looking like a quadratic yet. Let's take a look at this one. Again, this is a little different. So we're going to say U equals, and I always say to students, represent it by the middle term. So it's going to be the square root of H. That's what's so easy about this is I didn't change up my strategy at all. I say let it represent the middle term with the to the 1st power. So then if you do U squared, if you were to square a radical of H, radical of H, you're going to get simply H. And that represents what we have here. So you have U squared minus 3U minus 10 equals 0. So the square root, what two numbers multiply together, not square root, but what two numbers multiply together create negative 10 that add up to negative 3, and that would be 5 and 2. So we're going to go ahead and say, well, that's going to be negative 5 and positive 2. And then we're going to go ahead and say, well, U equals 5, U equals negative 2. So then what does U represent is over here. So you're going to say square root of H equals 5, and the square root of H equals negative 2. Where in order to get rid of a square, you have to just simply, how you get rid of a square root is simply by squaring it. And so your answers are going to be H is equal to 25, and then H is equal to 4. So let's see what the answers are. And we have 25. Now, wait a second. Where did the 4 go? Okay, I'm going to explain. I love doing that. The thing is about the 4. Okay, now remember the value of what we do for substitution. You have to check answer solutions. So if you put in 4 minus this, if we go ahead and do this problem, what are we going to get? We're going to get 4 minus, and then this is going to be 2 times 3 is going to be -6 minus 10. Does this equal, question mark, 0? Heck no, it's going to equal -12. I mean, so that's nowhere near close to being equal to 0. So you go ahead and put in 25, and that will work. If you put in 25, and then you have 5 times 25 times, excuse me, hold on. The square root of 25 is 5 times 3 is going to be 15, all right, minus 10 equals 0, all right? So again, you put in 25, square root of 25 is 5 times 3 is 15, and then you're going to have 25 minus 15 minus 10, and that in fact does equal 0. So that's why the answer is only 25 and not 4. So you have to be careful with your answer solutions. It's called extraneous answer solutions. They work for the process, don't work for the solution, or they don't work for the whole entire equation. All right, so you throw it out. So that's, you got to be careful about that one. Now, question number 10. See, these are where it gets more interesting. See, these are the ones that I want to make sure to go over because they are complicated for students with the negative values. All right, so now I bet you can figure out what I'm going to write. U equals a to the negative first, and then u squared equals doubling that would mean, or because you're squaring it, would mean it would be a to the negative second. So that means we have u equals, or u squared plus 9u plus 8. Two numbers that multiply together create 8. That add up to 9 is 9, or 8 and 1. The factoring part becomes really, really simple when you set up the U-substitution. And now we go ahead and say u equals -8 and u equals -1. Now we go ahead and do the substitution back in. Then we have a minus, or a to the negative first equals -8. And then we have a to the -1 equals -1. Now, one thing I have to let you know on how this really works is that you can look at it from this perspective, that really a to the negative first seriously means just 1 over a. 1 over a. Now, that's a heck of a lot easier for most students to process what to do with that. Now, all you have to do is multiply both sides by a and then divide by -8. And another thing I just tell students is just switch these two values and you'll get your answer for both a. All right. By the way, this should be a 1, not another 8. Okay. So my answer then becomes, if I switch them, a equals -1/8 and a equals, and if I switch it, just -1. Okay. So we have our answers. All right. Look at that. I love getting it right answer. It feels good. All right. Go ahead and let's take a look at number 11. Now, that is an incredible strategy that I'm going to use again and again and again. Obviously, I'm doing it over and over and over again. So let's take a look at this one. It looks intimidating with these fractions. Oh my goodness, can't do it. I'm shutting down. There's fractions. I hate fractions. A lot of students tell me, at least. So the thing that I want to do is I want to bring this over at the same time that I do my U-substitution. So my U-substitution is u equals m to the 1/3 power. And then that means u to the second equals m to the 2/3 power, because if I just go ahead and square it, 2 times 1 is 2. So that works out. So I have u squared minus 7u minus 8 equals 0. I've set up my U-substitution. Really simple now for me to go ahead and factor, which is what's really complicated if you don't do U-substitution. So now I'm going to go ahead and factor it. So u, what's two numbers multiplied together to create -8 that add up to -7, and that would be -8, and then +1. And then I go ahead and say that u equals 8 as well as u equals -1. And then I have my two values. I'm going to go ahead and say, well, what is u equal? Is m equals, or u equals m to the 1/3, m 1/3. And then I'm going to go ahead and say equals 8 and equals -1. And then how do I clear out a 1/3 for the fraction? Is simply just by raising it to the third power. That's how you clear it. It's so easy to clear out 1/3, just raising it to the third power. Third power, that wipes out that wipes that out. That leaves me with m equals, all right, because that's what we're looking for, is 8 times 8 times 8. Nope, not there. Not there. It's not coming to my mind. I'm normally pretty good about these things, but raised to the power of 3. Man, 512. I know them pretty darn well. I should have recalled it, but oh well, I didn't. So now you have -1 times -1 times -1 is -1. So you have two answers here for this. Okay, let's see what happens. And it looks like we have the same answers. There's -1 and 512. Okay, so we have that answer. Now, this should not be alarming for doing this one. All right, I've done that. It's kind of like the same as doing this one with fractions. All right, now we have this question, number 13. It looks a lot different, but it's not. Watch how simple it is. It looks so intimidating because of how it's structured. But now that I've given you strategies for how to approach these, you should find similarity in the approach. Is that I bet you can figure out what u is going to represent. It's right here. So u equals this. All right. And if that's the case, we know that u squared is going to be this. So we're going to go ahead and say u squared minus 4u plus 3 equals 0. And then what two numbers multiply together to create +3 that add up to -4, and that'd be -1 times -3. All right, so we have that. And then, of course, then we have u equals +3, u equals +1. And then u is represented by t plus 5, t plus 5. And then that means t is equal to -2 and t equals -4. All right. And of course, you always want to make sure you double check your work, but I'm being a little lazy today and not checking it because it does say you have to check your answer solutions if there's a possibility of no solutions. So there always is where you should check your answers, but I'm going to default to the fact that I kind of can see that there is not a problem with it. So I'm going to go ahead and release the answers, and they're the same. Okay. So, all right, because it's a fraction, I'm going to run with this one, and then I'll do the last one for this lesson. All right. So you have, I know people love fractions. Now, here's what I'd have to say to you. By me doing the one with the negative exponential power, I'll have to say to you that this is all you got to do is raise this up to the -2nd, like this, that I just did, and then go ahead and do the same thing for this, and then do your U-substitution. That's how I'm going to leave it. I'm not, because I've already done it. I already done that problem with you guys. I did it when I did this problem right here. It had the -2. This is the same way as me writing this. And the 9 times 1/a. All right. This is the same exact number system, but you didn't know about it. And now that I've written it this way, or from here to there, you understand why it's taking on this approach. All right. So then I'm not going to continue to do that problem. I just want to make sure that because I had a fraction, with k's that bring it back to simplicity of what I did here, and then you got the answer, and you know how to approach it. And that concludes this lesson right here.